We're going to continue our discussion on how to handle triangles that are not right triangles with the law of cosines. So there's a couple of interesting facts that came out of the book that I'm just going to highlight for you real quickly. This is a picture from the Dinosaur Park, Dinosaur Valley State Park, here in Glen Rose, Texas. And it's a really cool place to go to because there's these footprints that have been preserved there. And the author of the book tells a story about how you can calculate, how you're able to calculate the type of animal, the type of dinosaur that they were looking at using the law of cosines and to determine the gait that their walk. So maybe you're trying to decide whether it was a carnivore or an herbivore. So I thought that was kind of interesting, and I would encourage you to go into the text and just read a little bit about it. And then the other thing I'm going to point out to you is there's an interesting derivation of how do you actually derive or come up with the formula for the law of cosines. And it is, remember, we can't use the Pythagorean theorem or just regular old trigonometry if we're using a right triangle. And so this is the formula that was, or this is the derivation of how you can come up with the law of cosines, and I would encourage you to read over it as well. So we're going to jump into, though, how do I go about, what is the law of cosines and how do I go about using it? So the law of cosines is really what I'm going to use when I know the sides of a triangle. And that's what the formula kind of talks about here. Now there's three different versions of the formula depending on what it is that you're looking for. If I know two of the three sides of my triangle and an angle across from the side I'm trying to find, then that's when I would use the law of cosines. And you can see here that it just depends on which angle or which side I'm trying to find as to which version of this formula that we're going to use. So this is what we're going to talk about here in this first video. So if I wanted to apply the law of cosines, I have this example here that says that a surveyor wishes to find the distance between two inaccessible points, A and B, on opposite sides of the lake. So we have this point here and this point here, and we're trying to figure out, well, what is the distance across the lake? So while standing at point C, she finds that the measure from A to C is 259 meters. The measure from B to C is 423 meters, and the angle here in between those two sides measures 132 degrees 40 minutes. So we kind of have to remember how to do degrees, minutes, and seconds on our calculator. But the question is ultimately asking me to figure out what is the distance across the lake. And we're going to use the law of cosines on this because remember, if we wanted to use the law of sines, although I have this angle measurement here, the law of sines says it's the ratio of a side to its angle. And I don't have enough information here to be able to use the law of sines because I have a side here, but I don't know what its angle across from it is. And I know this side here, but I don't know the angle across from it. So the other option is going to be to use the law of cosines. So I'm going to call this side over here side little c, just to be a little clearer for what we have. Since this side is across from angle B, I'm going to call it little b, and this is little a, just to put it into the formula easier. So I'm solving for side C. The formula tells me that it's side C squared equal to A squared plus B squared minus 2AB times the cosine of angle C. All I've done is rewrite the law of cosines from our formula box from above, and we're going to fill in our missing pieces here. So C squared, or C, is what we're looking for. I know that A is 423 meters squared. I know that B is 259 squared minus 2 times those numbers, 423, 259, times the cosine of 132 degrees 40 minutes. So now it just really becomes a calculator problem to make sure that we can come up with the answer that we're looking for. Okay, so I pulled up my calculator, and you have many ways that you can put this into your calculator. I happen to, since I was solving for everything on the same side of the equal sign, I just put the whole thing into my calculator. You can see here that it's highlighted in blue that I have angle A squared plus angle B squared minus 2 times angle A times angle B times the cosine of, and I don't think you can see it, but I have the angle 132 degrees 40 minutes. Now if you have forgotten from the beginning of the semester how to find the degrees and the minutes button on your calculator, you're going to go to Second Apps. So Second Apps brings up the degrees and the minutes button, and you would use that in order to put this angle that was given to us in the problem into your calculator. So you can see when I put that whole string in that I ended up with that large number of 394,510. I highlighted in blue. But don't forget that when I'm solving for the side using the law of cosines, I now have to take the square root of that side, and which I did here, giving me a side of 628 meters if I was to round to the nearest whole number. So C ended up being 628 meters. So it's kind of a straightforward, as long as you can get all of the values put into the formula in the right order, then it's just a matter of being able to work your calculator to come up with the answer. I just would caution you though that I have seen many times that students are able to get to this step here, but they forget to take the square root as the final, in the final part to get the answer that we're looking for. So that's just a simple application of the law of cosines.